We are going to study a unit cell of body-centered cubic arrangement. Means atoms will be at corners of a cube and atom will be at center of the cube. Atom along the body diagonal, along the cube diagonal, they will touch each other. That will help us to find a density within BCC crystal lattice. We need to bear in mind these 6 points to find packing density of any crystal lattice. First point is structure of unit cell. Where are the atoms situated? How do they touch each other? Where is the continuity in the linking of atoms? What are the cell parameters? And some mathematical base. So second point is we need to find total number of atoms present in the unit cell. By knowing the location, you can find that small n value. Third important thing, we need to find out total volume occupied by atom per unit cell. If we know number of atoms, then by knowing the formula for volume of sphere or volume of atom, we can find out the net volume occupied. That's a small v. And fourth point is capital V. We need to know how much volume is available for occupation. Simple cubic structures are there, so A cube will be the volume. Fifth point, we need to determine the relation between A and R. For that, structure should be very clear and little geometrical aspects are necessary. We will discuss them. And sixth point, actual calculation of packing density or packing efficiency. The formula is small v divided by capital V. Answer will be in fraction. To that fraction, if we multiply by 100, we will get answer of packing density or packing efficiency in terms of percentage. Let us see the structure. See in this diagram, by blue sphere, atoms are represented. You will find atoms are at corners of a cube and one atom is there at center of a cube, that we say as body centered atom. It is three-dimensional arrangement. In order to make it clear, schematically, it is represented making the atoms very small. So left side diagram is a representation for BCC, atoms at corner and atom is at center of a cube. You will find line joining from one atom to other cornered atom. So along body diagonal, dotted lines are represented. See the right side diagram. There, the portions of atom which belong to the unit cell, those are represented. So little portion is there from the atom at the corner and complete atom is there in the unit cell, which is at center. So after knowing this structure, let us find number of atoms. Total number of atoms in BCC arrangement is equal to 1 upon 8 into 8. Why for 1 upon 8? Because atom at corner has contribution to the unit cell only 1/8. And why 8? Because such 8 corners are there in a cube. Therefore 1 upon 8 into 8 is equal to 1. Plus atom at center of the cube is there. Its complete contribution there. So 1 into 1. What is the total? 2. What does it mean? 2 atoms are there in one BCC unit cell. From total number of atoms belonging to the unit cell, we can find out volume of atoms per unit cell. What is the volume of sphere? 4 by 3 pi r cube. Such how many spheres? How many atoms are there? 2. So total volume will be 8 by 3 pi r cube. That's the volume of atoms per unit cell. And that much volume is occupied by atoms from unit cell. How much volume is available for occupation? That is our capital V. That's the volume of cube. What is the volume of cube? Side raised to 3. What is side? Small a. That's our cell parameter. So a cube means capital V. To obtain the relation between A and R, the arrangement of atoms you need to understand clearly. For the sake of clarity, one of the atom at right corner is not represented. You will find the atom at left bottom corner connects to atom at center of a cube, which connects to right back corner. Means along body diagonal, atoms are touching each other. Those are represented by green color. Now to find the relation between A and R, we need to express that body diagonal of a cube in terms of A. This we can do by simple application of Pythagoras theorem. For that, let me label atoms. A, B, C and D is at the bottom but behind. E is our body central atom and F is right back atom. So we are interested in distance CF, means body diagonal. But to find that CF distance, let us find first face diagonal, that is AC. By Pythagoras theorem, AC square, that's the hypotenuse of right angle triangle, is equal to square of right angle making sides. Means AB square plus BC square. What is AB? It is a side of a cube, small a. What is BC? Side of a cube, small a. So what is AC square? 2a square. Means what is AC? Is equal to root 2a. Yes, I represented there, see. Face diagonal, root 2a. Now we know face diagonal and one of the side. So let me consider side as FA side will form one triangle. I repeat, face diagonal, that is AC, one of the side, that is FA, and our hypotenuse of the triangle or body centered diagonal, that is CF. So now I want to consider right angle triangle FAC. So FC is hypotenuse. FA and AC are sides of right angle triangle. Again apply Pythagoras theorem. Hypotenuse square means CF square is equal to one of the side FA square plus other side AC, that's a face diagonal, AC square. So substitute the value. Side length is A, means CF square is equal to A square plus root 2A its square. So what is answer? 3A square is equal to body diagonal square. So what body diagonal CF? CF is equal to root 3A. And what is CF? It is the connection between three spheres. So from one of the spheres, say C if you start. So it is the radius of atom C. It is the diameter of atom E and the radius of atom F. So total how many radii are there? 4. So CF is equal to 4R. And what is CF? Root 3A. So root 3A is equal to 4R is a relationship. So if you have to simplify, A is equal to 4R upon root 3. Remember this formula. That will help you to solve the numericals. What is the formula of packing density? Volume occupied by atoms, small v, divided by total volume available for occupation, capital V. Substitute the values those we found. What is the value of small v for BCC unit cell? How many atoms are there in one unit cell? 2. One atom has volume 4 by 3 pi r cube. So 2 atoms will be with volume 8 by 3 pi r cube. Therefore in numerator 8 by 3 pi r cube is represented. And for capital V, simply side raised to 3 a cube is represented. In second step, substitution for the value of a is done. What is a? A is equal to 4r upon root 3. See, keep in bracket. Raised to 3, a cube is there, no? So 4r upon root 3 raised to 3. Carefully simplify that bracket. 4r raised to 3 means 64r cube. And root 3 raised to 3 means root 3 into root 3 into root 3. means 3 root 3, that is represented in numerator. 8 as it is represented, and in denominator you are finding 3, it is because of the denominator in the numerator function. So 8 by 3 is there, 3 root 3 is there, and 64 is there. Remaining things pi r cube, and below that r cube. So who will get cancelled? 3 and 3 will get cancelled. R cube and r cube will get cancelled. And 8 is 2, 8, 64. So final answer is in purple color represented root 3 pi upon 8. Simplify. Root 3 means 1.73. Pi means 1.42 is equal to 0.68. Yes, 0.68 fraction is occupied by atoms in BCC crystal lattice. It means how much is not occupied in terms of fraction? 0.32. Let us represent it in terms of percentage. How to obtain percentage? Fraction into 100. So percentage of occupation of space by atoms in BCC crystal lattice. It may be unit cell or it may be lattice. How much percentage? 68 percentage. Means how much is unoccupied in terms of percentage? 32 percentage. Yes. Two questions are there for you. How many atoms do remain present per unit cell of BCC arrangement? And second question, what is the relationship between A and R for BCC arrangement? Just write question number and the answer in the comment box. I am waiting for your answers. Yes, still there remains a lot of space empty. Let us study one more cubic crystal, that's a FCC, in next part.
Like a bird on